Thank you. It's good to be back here with the Mars Society. Some of you may remember my talk a year ago when I thought that the first step towards Mars was to set up a base on Deimos. First, can you all hear me okay? I've changed my mind. I now see 3 easy steps to Mars, to actually landing on Mars and setting things up there. I will not discuss that because that's a little bit far in the future, at least as far as I'm concerned. I've been at this for about 35 years. I'm getting impatient. I want to see a manned Mars mission, and I have yet to see one. I even have yet to see one that's being seriously planned by NASA. So I'll say a few political things first. Then I'll say a few scientific things. And then I'll talk about space operations, projects, the 3 easy steps. I've been inspired by Dennis Tito's inspiration mission. I used to think that flyby of Mars is very simple, but is it worthwhile? I now believe that it could be worthwhile, and that's basically why I changed my mind. I'll show you. First of all, political things. I have many colleagues, academics, who are against manned missions. They say, who needs manned missions? We can do everything we want with instruments. They're wrong. There are some things that can only be done by a man or by a human. I have to be careful here, man or woman. Furthermore, without manned missions, there would be no NASA. I hope NASA realizes that their existence and continued well-being depends on having manned missions. Curiosity is very nice. It won't accomplish the job. It won't supplant a human geologist. It can do many things, and it will. It's a tremendous technical achievement, and so are some of the other unmanned missions. But my prediction is that Congress will not fund them. They'll stop unless there is a definite manned goal to drive the Mars exploration business. Everything that NASA is doing now, which they call steps to Mars exploration, I consider to be detours, ways of delaying what we should be doing. I have nothing in principle against the moon base, except it's not a step towards Mars. It'll just take another decade or 2 of delay. Occupying libration points, that's not a step towards Mars. We don't need it. Mars can be reached directly. One of the worst things is what NASA seems to be doing right now, which is to capture an asteroid, drag it into lunar orbit for manned exploration. It's unbelievable. It's stupid. We have pieces of asteroids in our museums. They're called meteorites. And they have been examined by humans for the last few decades. There are about 20 or so kinds of meteorites. We've learned a lot about asteroids from these meteorites. We don't need a manned project which will occupy another couple of decades and delay a Mars mission further. So I say, let's go to Mars now. Why do we wait? We don't need the fancy technologies. We have them. We don't need nuclear rockets. We don't need plasma rockets. We don't need electric propulsion. We have it anyway. We don't need heavy lift vehicles for what I will be discussing. These are all very nice things, and there are lots of very good engineers who've been working on them who would like to see them come to fruition. But we don't need them to explore, to have a manned exploration of Mars in the way that I will describe in a minute. Fundamental science goals. There's so many. I won't read what I have written here. But basically, we can learn about the Earth by studying another planet, and that other planet has to be Mars. There's nothing else in the solar system that resembles the Earth. Climate history. Again, we must study Mars and see if our climate models, which kind of work on the Earth, kind of don't work, depending on who you talk to, whether they work on Mars. A model is a model. It ought to work. And finally, the origin of life. We know that there's an origin of life on Earth. There may have been several origins. We don't know that. But we need to find out if there was ever a chance for life to develop on Mars, if there's fossil life, remnants of past life, or even crypto life, life that exists now but is hidden, and if it developed in the same way. These are very fundamental scientific issues. And Mars is the key to all of these scientific issues. Okay, I'm finished with science. Let's now talk about missions. As you know, I've been a proponent of exploring the moons of Mars, of setting up a human base on Deimos. The moons of Mars have their own scientific fascination. To me, they're as fascinating as Mars itself. In fact, I think that the moons of Mars will turn out to be the key to understanding the early history of Mars. How did Mars develop? How did the moons get there? Are they captured asteroids, as some people think? It's very funny. My first paper on the moons of Mars was published in 1968. That's 45 years ago. And I speculated that they might be captured asteroids. That is obviously wrong. I don't believe this anymore. But somehow, this found its way into the textbooks. And if you Google the moons of Mars, or if you look in a textbook, you'll find out that they're captured asteroids. They can't be captured asteroids. It's completely improbable. But then again, I don't know what they are or how they got there. We need to find out. It's one of the great puzzles in the solar system. By the way, for purposes of politics, it's good to pretend that Phobos and Deimos are captured asteroids. Maybe we can persuade NASA to get little chunks of Phobos and Deimos so we can examine them. So I'm willing to play along on this issue. And for a moment, I will forget that I'm against their origin as captured asteroids and pretend that perhaps they could be that. And maybe NASA can be persuaded to get chunks of Phobos and Deimos. Okay, 3 easy steps to Mars. You recognize, of course, step number 2. Step number 2 is what I call the Dennis Tito mission. It's an important mission. It can be made scientifically important by having autonomous rovers that will collect samples from Phobos, Deimos, and Mars. But I don't think that Tito can get his mission off by 2018. That's not how things work. Believe me, I know. I've been through many space missions. So we must have step 1. Step 1 is an unmanned Tito mission. It's as you know, a free return mission. It is a flyby to Mars with a free return, a boomerang kind of mission. It might be able to do it 2018 launch. I'm not betting on it, but it's possible. It can do important things. It can test re-entry. It'll come back at about 15 kilometers per second. That's faster than any satellite has ever come back. We need to test that and understand it well before we do step number 2, which is the manned mission. We can probably do a sample return from Phobos and Deimos. It'll take a lot of very clever engineering to design autonomous rovers which can be released from this unmanned Tito mission, collect the samples, preferably drill down past the regolith, get samples from both regolith and deep down, and bring them back to the main mission so that we will have them when the main mission lands on Earth. In other words, I can see a scientific rationale for step number 1, and that's very important because politically speaking, we have to get the academic side on our side and we have to get the engineers on our side. Those people are not necessarily Mars enthusiasts, but they're fascinating scientific problems that can be settled. For example, are Phobos and Deimos made of the same stuff? Are they related or are they independent? Does anybody know? I don't. I don't see anybody in the audience who knows. Would you guess? I would guess that they might be the same, but they look different. Why is that? Well, step number 3, finally, is my original mission to set up a manned laboratory, a manned base, and a complete laboratory on Deimos, the outermost moon, and from there explore the surface of Mars and everything else about Mars with unmanned robotic rovers, which can bring back samples to Deimos that we can examine, fresh samples that we can examine and then send back more rovers to do the job. I visualize something like maybe 24 rovers. We can afford to lose a few. Unlike the present unmanned missions, where you send one rover and if you lose it, you've lost the mission. That's not how you should operate. That's not the way to win. So, adopting now the language of our former chief of NASA, we need to do things sooner, better, and cheaper. Dan Golden. I don't know what happened to him, but in many ways he was very good. So was Mike Griffin. We need good technical people. We're going to have a new administrator of NASA come next month. Catherine Sullivan will certainly be approved and sworn in. I know very little about her. I hope she knows something about Mars. If not, we need to talk to her. Okay, why can we do step number 3 sooner? Well, basically because it's just an orbit transfer from Earth to Mars. It's a simple mission, in a sense. Of course, nothing is ever simple. But it sounds simple. Orbit transfer from Earth orbit to Mars orbit. And Deimos does all sorts of wonderful things for us. And I put down builds on ISS experience because we must keep people happy in NASA headquarters who've spent $100 billion on ISS and haven't achieved very much. But the main thing is there are no showstoppers. It's a simple mission to reach Deimos orbit, to land on Deimos, and to set up a laboratory. And it can be done fairly quickly. And it's better. It's better than a series of unmanned rovers. Each unmanned mission requires planning and will take between 5 and 10 years. Can you see 5 missions, successive missions, over the next half century? Can you see Congress funding those? I can't. But I can see them funding the Deimos lab, which will have 20 rovers, which will give us lots of chances to explore Mars. That's what we want. The important thing about this from a scientific point of view is that it gives you sequential exploration. When you find something interesting, you can immediately, within hours, send back another rover, get another sample. You don't have to wait 10 years. That's very important. It makes all the difference. Another thing that you may not recognize or realize, you can set up a complete scientific lab on Deimos. In fact, it's simpler than any lab on Earth. Why? Well, I've operated labs. The big problem in labs is the vacuum system. It always leaks. At Deimos, you have a vacuum system free of charge. And the instruments, whether they're mass spectrometers or electron microscopes, are extremely simple and very cheap. Once you're on Deimos, you can consider sending a manned sortie to Phobos, or an unmanned one, and collect samples from Phobos. And then you have samples from Deimos and Phobos, and you can make sensible comparisons. I think one can even set up something that Robert Zubrin has long advocated on the surface of Mars, a prototype automatic propellant factory, and see if it really works. I think it will. But let's demonstrate it. Finally, cheaper. You know, this mission is amazingly cheap. I did some calculations, very simple ones, back of envelope calculations, using the numbers we now have for SpaceX. The cost of SpaceX is well known, and its capability of putting payloads into low Earth orbit is known. We need 30 tons in low Earth orbit. Most of that is propellants. The cost of setting up, of sending the stuff up to a low Earth orbit, the cost of setting up the propellants is 5% of the cost of the mission. Most of the cost of the mission is engineering. Propellants are cheap. SpaceX is cheap. Do the calculation yourself, and you'll realize that there's no need to save on propellants. There's no need to save on propulsion. Use as much propulsion as you need. Use as much propellant as you need. The rocket doesn't have to be the best. It just has to be good enough. And chemical rockets work. We know that. They worked before, they'll work again. That's all we need. Just chemical rockets. We can even pre-position most of the stuff on Deimos and then send the manned component later on a faster route if we so desire. I will mention one more thing about propellants, why they're good. Propellants make the ideal shielding against space radiation. Not lead, not metal, but hydrogen-containing propellants. Light nuclei, on a weight basis, make the best shielding. Trust me, I've gone through that exercise. It means that the design of the transit vehicle has to take that into account. It has to be surrounded by propellants. Once you get to Deimos, things become easy. Deimos provides shielding at least for half of the full steradian. You can build a shelter from Deimos rocks and all kinds of things. You can also shelter against solar flares, high-energy particles from solar flares. You simply go to the other side of Deimos. You can shield against meteor showers. You go to the other side. These are directional. They come only from one direction. It's simple. Deimos is a very handy shielding device. I'm in favor of having a nuclear reactor as a power source. They work. They've been developed. You can buy it. You may have to buy it from the Russians, but why not? You put it out for bid. If they're the low bidder, buy it. What do you do with it? Well, you put it in one of the Deimos craters, put a long cable to the lab, and you're in business. You have remote cutoff and remote turn on. And when you're finished with your operation, you leave it there for the next operation. Then you have a permanent power source of around 50,000 watts, 50 kilowatts. That's pretty good. You can't do that with solar or in any other way. So I like nuclear reactors. Some people don't. Oh well. You can always use chemistry and fuel cells. I prefer nuclear reactors. Now the $30 billion figure that I had there within the present NASA budget, that was as of 10 years ago. It may be a little more now. Maybe not. It depends on how you cost it out. It depends on what you have to do to get there. It depends on who your partners are. If you have international partners, they can bear some of the cost. And now, the best thing about this PhD mission, as I call it, the manned robotic mission, and I will now compare it to a manned base on Mars for the purpose of scientific exploration. That is for the purpose of first steps only. I'm not against a manned base on Mars, but if you want to do science, the first steps, you're better off staying on Deimos and using unmanned rovers, robotic rovers, to do the work for you. And here's why. Since you don't land on Mars and don't take off from Mars, you don't need a high thrust rocket. The whole thing can be done with low thrust, a single low thrust rocket. If you want more thrust, more delta V, you just run it for more seconds, a longer time. So you get any delta V you want. You don't deal with big gravity problems here. So there's no need for high thrust engines. No landings, just orbit maneuvers, which is safer. So we can use existing engine, smaller, less weight, better mass ratio. What else can I tell you? In fact, we can afford to have two engines. In case one conks out, you have a spare. Why not? A Mars base has problems. In the first place, Mars is a big, big planet. You can't travel, a human can't travel around Mars. If you want to put rovers on different parts of Mars, you still have to have a communication system to control them and to bring back the information. You might as well be on Deimos, where you can watch them. Also on Mars, you have dust storms. You're exposed to solar flares. You're exposed to asteroid impacts. You're exposed to cosmic rays. And you don't have a vacuum. So it's hard to operate instruments. You'll need to make a vacuum if you want to operate on Mars. Then there's a question of biological contamination. I don't know much about that, so I'll skip over this. But many people think that's extremely important. Backward contamination and forward contamination. Between Phobos and Deimos, Deimos is the best choice. You can watch rovers from Deimos for up to 40 hours before they disappear on the backside of Mars. Deimos is in an almost synchronous orbit. You can see most of Mars, almost all of Mars, from Deimos. It's easier to get to. And it's not as deep in the gravity well as Phobos is. So you don't expose yourself to the same kind of meteor showers. They come in at lower velocity. Easier. It's an easier operation. Well, of course, you can have futuristic follow-ons. I've listed here a few of the most popular ones: Mars base, habitation and colonization, propellant production, detailed exploration experiments, and even terraforming and agriculture. I don't know if Chris McKay is here, but if he is, he'd be happy to see that I mentioned terraforming and agriculture. By the way, Phobos and Deimos make very cheap sources of raw material. They're the cheapest source of raw materials in the solar system. Why? They're far away, to be sure, but from a gravity point of view, they're easy to reach. They require very little propulsion to bring them back towards Earth. So Phobos and Deimos are cheaper and better than any asteroid and certainly better than any planet. Um, I'm merely finished with my discussion. I think I can summarize now. So let me summarize before we go on to a discussion. I see 3 easy steps to Mars, which hopefully we can do within the next 10 or 20 years. But to be frank with you, this is a hope. I can see NASA putting up all kinds of obstacles, claiming that these are steps to Mars. Remember, they're detours. They simply delay a real Mars operation. So if you have any influence among your friends or with people who are in NASA or in government generally, please preach the fact that we can go to Mars now, right now, with what we have. We don't need any more development. There are no showstoppers. We're ready. Thank you very much.
Dr. Singer, how far out is Deimos, and do you see any utility of, say, a graphene-based space elevator cable hanging down into the top of the Martian atmosphere to make transportation between those two objects a little more achievable?
Love it.
Is there any use of having a space cable to make transportation between a space elevator between the moon and Mars?
I once submitted a proposal to NASA with Ivan Becky. Do you know, some of you may know Ivan. Ivan Becky, formerly of NASA, he's a big Tether fan. And we thought of building a tether between Phobos and Deimos. It never got approved. Sorry. Nice idea. It'd be nice to have a tether between Phobos and Deimos. There are all kinds of problems, of course, but that's what we're here for, to solve problems. By the way, I just want to say a few more words. Do I have time?
Yes. 8 minutes.
8 minutes. A few more words about protecting humans on their mission to Mars. It may turn out, depending on when they leave Earth or Leo, it may turn out that they may have to spend several months in the vicinity of Mars. That's more than we bargained for. Radiation protection, no problem. No problem at all. I know how to do that. The problem I see, and finally, life support system. Nothing fancy. We just put in more food, more stuff. And we take the waste material and leave it there. No need to recycle anything. We don't have to solve that problem at this time. The problem I see, and I don't know much about that, is the zero gravity problem. You have zero gravity on the way to Mars, and you have zero gravity, essentially, on Deimos. It has practically no, it's microgravity. We may have to have a device that produces artificial gravity. I think this is something to think about or something to work on. There are people who are better qualified than I am to handle this business, but if you're going to spend, if humans are going to spend several months at zero gravity, they may need special devices. Not a problem. We know how to do it, but it's just a complication.
Um, have you looked at the Phobos supersonic, not hypersonic cable or elevator? That would skim just above the atmosphere of Mars at about 1,200 miles an hour. That's less than 3%, less than 7% of what we need to get to Leo, and if you make it out of Kevlar, it would be it could lift its own payload. So if you made it out of stuff that's much better, it would be able to carry more than the weight of the equipment.
What's the question?
So any benefit to a supersonic cable from Phobos into the Martian atmosphere?
That's only 1,200 miles an hour.
I have not thought about this,
Which
but
means
it's worth exploring.
Which means you could drop stuff at only 1,200 miles an hour.
But let's
so you
not
wouldn't
hold
need
up.
heat shield. Pardon me?
Let's not hold up to do this. Let's go ahead with what we can do now.
It's what we have. I don't need the.
A few more remarks
nanocables or
about
anything.
Phobos. I don't want to shortchange Phobos. You probably all know that Phobos is on its last legs. By this I mean it's spiraling inward towards Mars because of tidal friction, and it'll soon be gone. When I say soon, I mean maybe 5 million years. Okay. No hurry, but soon in terms of cosmic time. I'm of the opinion that there may have been other moons of Mars which have now disappeared. We need to find their remnants on the surface of Mars. They would have spiraled in more rapidly. The lifetime is inversely proportional to the mass. So the most massive moons would have spiraled inward. By the same token, I would look for micromoons that may still be in orbit about Mars between Phobos and Deimos. Phobos is about almost less than 3 Martian radii from the surface of Mars, and Deimos is about 6.8. So somewhere between 3 and 6, we might see some very small moons in orbit about Mars. They will live for a long, long time, long after Phobos is gone. And of course, Deimos will live for a long time because it's not spiraling inward. It's actually spiraling outward, but very, very slowly. These are speculations, but you know, one needs to speculate in advance of finding these things. It would be fun to look for them. Another thing to look for, in my view, are dust clouds about Mars. After all, when meteors impact on Phobos and Deimos, they generate a lot of dust. Where does it go? Well, it stays in orbit. So Deimos may be surrounded by a dust cloud, which we need to study, and Phobos may or may not be surrounded by a dust cloud. Why? Because it's so close to Mars that Mars' gravity field will grab the dust and accrete it to Mars. One needs to calculate that. I promised myself I would do that, but I never got around to it. It's a difficult problem.
So, yeah, we'll take one more question. And then
Yes,
we'll wrap it up.
you didn't address the problem of how you get the samples from the surface of Mars up to Deimos, and would you just say something about that? Surface of Mars to Deimos.
How do you get the samples from the surface of Mars to Deimos?
Oh. How do you get the samples from the surface of Mars to Deimos? Simple. You hire good engineers. It's an engineering problem. It's a challenging problem, but certainly I think it can be solved. And incidentally, the autonomous rovers for step 1 and step 2 would face an even more difficult problem because they would have to leave from the spacecraft, get to Phobos and Deimos, collect samples, and find the spacecraft again on the way back. We have great engineers working for NASA. I'm sure they can tackle this problem, and it's an important one. Thank you.
Okay, thank you, Dr. Singer.
I'll sit down.